Okay, so this lecture will be recorded, posted to YouTube. Everyone should know where to find that. Okay, I've also posted some links to other YouTube channels. Some of them are specifically on integral type questions. Okay, so you can have a look at that. Just be careful, some of them require techniques we haven't done yet. So just go through it, see if you can do it yet. If it looks too difficult, we're going to be covering that later. Yeah, so if it does look too difficult, don't worry, we will get there. This is still early days. Okay, so use substitution. Okay, remember from last time, we had this integral f of g of x, g prime of x dx. Okay, so we had some outside function f, some inside function g. It looks a bit complicated like this, but if we do the use substitution, u equals g of x, then du becomes g prime of x dx. Okay, from now on, I'm going to leave out the du by dx. Okay, everyone should know how to find that. So this now becomes the integral f of u, since g of x is u, and then g prime of x dx, that's just du. Okay, and we end up with the simpler form. Okay, we've seen that from yesterday. Now, the best way to learn use substitution is through practice. Okay, looking at one example, that's not going to help. 2 examples, that's not going to help. Today, we're going to go through 20. And then in the tutorial, you're going to carry on with even more. Okay, you have to practice at this. Okay, later on, when we do more integration techniques, it's going to be a bit difficult to find what you need to do. Is it use substitution? Is it something else? The only way you're going to get good at that is through practice. Okay, so number 1, we have the integral sine of x square root of 1 plus cos x dx. Okay, we have a couple choices for u. However, we've only got one part of this where there's an outside function and inside function. We've got the square root, that's outside, 1 plus cos x, that's inside. Okay, so that inside part we should let be u. So we're going to say u equals 1 plus cos x. So du is, the derivative of cos is sine or minus sine? Negative sine, yeah. So minus sine x dx. Okay, that's almost what we want for that first part. In the question, it's just sine. Over there, on the right there, it's minus sine. So we're going to have to take the minus over to the other side. So we have minus du is sine x dx, which takes care of the first part with the sine x, and that last bit with the dx. So we can rewrite this a bit better. So we have 1 plus cos x sine x dx. So the first part, roots 1 plus cos x, that just becomes roots of u. Sine x dx, that is going to be minus du. So we put all of that there. Okay, minus is just minus 1. We can take it out to the front. It's just a constant. Root of u, that's u to the half. We can fill that in. Du. Okay, quite easy to do. Add 1 to the exponent, that's 3 over 2. Divide by that, that's 2/3. So we have minus 2/3 u to the 3 over 2, and again plus c. Whenever it's an indefinite integral, it's always plus c. Okay, but we're not done yet. This answer is in terms of u. The question is in terms of x. So we need to put the 1 plus cos x back inside. So that's going to be minus 2/3 1 plus cos x to the 3 over 2 plus c. Okay, any questions on this one? All good. Okay. Okay, number 2, we have the integral of sec squared x tan cubed x dx. Okay, these types of problems we're going to look at specifically in a couple weeks. Anything with trig functions like this to various powers being multiplied, These are called trigonometric integrals. We're going to look at this specifically in a couple weeks. Okay, but for now, we're just going to treat it as a U substitution problem. So we have two options. Either it's sec or either it's tan. One of the two. Let's look at sec. If u is equal to sec, du will be sec tan. Okay, that doesn't really help us here. We've got tan cubed, so that's not going to work. What happens if u is tan? What's the derivative of tan? Sec squared. We've got that there. So that's what we pick. So you see, the first time we go through these problems, you try the first one, that doesn't work. You try the second one, it does work. Later on, you're just going to know immediately tan. Okay. And again, that just comes from experience. Okay, so for the first few, try things out. But make sure you learn that if you see something like this, it's better to pick tan. So u is tan. Du is sec squared. Again, I'm leaving out the step of du is du by dx. We should all know that. We don't need to include that now. Okay, so let's write this as the integral of tan cubed x and then sec squared x dx. So all of this on the end there, sec squared x dx, that just becomes du. And since u is tan, that beginning bit just becomes u cubed. So this is the integral u cubed from there, du from there. And then we just integrate. So u cubed, that becomes 1/4 u to the 4 plus c. Okay, so this step of integrating, that should be very easy for you now. Okay, whether it's a polynomial, a trig function, 1 over u, whatever it is, that should be very quick to do now. Okay. Okay, but we're not done yet. This is in terms of u. We want it in terms of x. U was tan, so this will be 1/4 tan to the 4. Again, plus c. Okay, number 3. Okay, so we have the integral x root x plus 2 dx. Okay, again, we've got some options. Yes? Yeah, so we just swap these two. So tan cubed becomes u cubed because our substitution was u is tan. So that gets replaced. Everything else to the right, that was du. Okay, if I don't see your hand up, just shout out. Okay. Okay, so here we've got x and then root x plus 2. If we say u equals x, that doesn't really help us with anything, so we can ignore that. That next term, square root, that's the outside, x plus 2, that's the inside. That gives us a clue. So u must be x plus 2. Okay, so that means du is dx. Okay, that's quite simple. But that takes care of the root x plus 2, but it doesn't take care of the x. We want x dx. So we did look at this a bit before, but what we're going to do is look at our equation for u, rearrange it to solve for x. So here, this is going to be u minus 2 is equal to x. So on the right-hand side, we can multiply by x. On the left-hand side, we can multiply by u minus 2. Okay, as long as you do the same thing to both sides, everything's fine. Now, x dx we can replace with u minus 2 du, and the root of x plus 2, that's just root of u. So this becomes the integral root of u minus 2 du. Okay, now it looks like we haven't done much. We've still got the root and we've still got the u minus 2 there, but u with the root is just u to the half. So this is the integral u to the half, u minus 2 du. And now we can just multiply them. Okay, before we couldn't. X and root x plus 2, you can't multiply that inside. That's not going to work. Here we can. So this is going to be the integral u to the 3 over 2 minus 2u to the half du. And again, from this step to the next step, it should be very quick. Okay, you shouldn't be taking too much time with these fractions. So 3/2 plus 1, that's going to be 5/2. Divide by that, that's 2/5. Minus 2 times. We've got a half. Add 1, that's 3/2. Divide by that, that's 2/3. And the all-important plus c. Okay, we're not done yet. This is in terms of u. Questions in terms of x. Let's put the x plus 2 back. So that's going to be 2/5, x plus 2 to the 5/2, minus, we can write this as 4/3, x plus 2 to the 3/2, plus c. Okay, no need to simplify from here. Once you've done the substitution, your job's done. Okay, number 4. Whoops.